So this is the problem we're going to do with sled and mass number 1 on friction. You have static coefficient of friction of 0.3 and a sliding, which is kinetic coefficient of friction of 0.1. What is the weight of the sled? So for part A, we have the force of earth is the weight, which is 50 kilograms times 9.8, which is 490 newtons. The picture for this pretty much looks like this when you have a sled being pulled along the snow. Okay, what force is needed to break the sled free from move? So it's stationary. I want to make it move. So that's frictional force holding in place, mu static times force normal. So here we have a force of earth, and then we have a force normal that is up. So in this case, that equals force of earth. Mu static is force of earth. So we have to use mu static, which is 0.3, times force of earth, which is 490. And the answer is 147 newtons. So it requires 147 newtons application of this way to break the force of friction, which is right here. Part C, what is the force needed to keep moving at constant speed? So force of friction kinetic now, times force normal, equals mu kinetic times force of earth again, which equals 0.1 that's 0.1 times 490, which is force of earth, which is 49 newtons. So to keep it moving at constant speed, it's 49 newtons. And then part D, once moving, what is the force required to accelerate? Well, when acceleration is 3 meters per second, F net is mass times acceleration, which is 50 kilograms times 3, which equals 150 newtons. So then F net equals add all forces. So 150 equals the force of friction plus force applied. Well, force of friction has to be frictional force kinetic, which is 49 newtons, negative 49 newtons, because it snaps direction to the motion. Force applied equals 150. So 150 plus 49 equals the force applied. So force applied equals 199 newtons.